Hello, I'm Ibram Sirleaf, and this is my Physics 2211 Lab 2 submission. Introduction. Purpose. The purpose of this lab was to examine and compare the experimental and actual velocity of time of an object tossed over a distance. Model. For the lab, we used a measuring stick to measure distance in the x direction and tracker to measure the y direction. We also used a spool of string that weighed 0.131 kilograms. Results. The final results were that on VPython, the trend line was y equals negative 0.861 plus 0.6446, while on tracker, the trend line was y equals negative 0.8176 plus 0.662. Models. So the fundamentals we used were the gravitational force, where Fg equals negative 9.8 meters per second squared times mass. Net force equals Fnet, Fnet, which equals negative b, the drag constant, v squared plus Fg. Then velocity update, which is Vf equals Vi plus Fnet divided by mass times time. And position update, which is Rf equals Ri plus V times T. Experiment. The initial conditions for our lab was that the system was the object that we threw, which in our case was the spool, and the surroundings was the Earth. Our initial conditions were that time was 0 seconds, the initial velocity was 0 meters per second, and the initial position was 0 meters. In order to perform this lab, we first weighed the object, then one of us held the measuring stick, then one of us tossed the object into the hands of the other, then finally we measured the data using tracker to find its x and y movement components. Code. So some of the code that we used was, of course, the initial position, initial velocities, the initial time, gravity constant, 9.8, and then the drag constant, which we had to figure out through multiple tests, and then again the mass, which is 0.131, and then we use the Fnet formula, velocity update, and position update formulas. Discussion. Some of the possible errors that could have come from this lab was 1, the placement of points on tracker. Of course, it's difficult to place points exactly where they need to be, so of course some error can come from that. 2, there was manipulation of the velocity and drag slightly on VPython so that we can get the correct arc to find the drag constant. And then 3, tracker measures over larger intervals while VPython measures over smaller intervals, which can lead to more error. Discussion. In this lab, velocity and acceleration were further explored in both the x and y dimensions, and these are derived from Newton's second law, force equals mass times acceleration. There's also brief usage of drag in this lab, and which comes from physics concepts related to friction. So the questions we were asked were: terminal velocity when a free-falling object experiences 0 net force. Examine the velocity versus time graphs with and without drag. Do any of your models predict a terminal velocity? Yes, the model without drag is much less steep. This is likely because no other force opposing gravity, although it is hard to tell on such a small time frame. However, the existence of drag does imply that there is a terminal velocity. Imagine if the object were initially thrown straight up with the initial speed in your experiment. Would the time the object takes to reach the ground be the same, longer, or shorter? So, of course, this would take more time, and this is based on the velocity update formula. Since it's going upwards for longer, the velocity initial is higher in the y component, meaning that the time of the movement is longer. Conclusion. The final findings are that tracker and VPython data are extremely comparable, and that over such a small time frame, drag has very little influence. The end.